Hi amigos, welcome back to my YouTube channel Mathsphobia. In the previous video, we have completed explanation of 2 mark questions of 2B. If you want to go check this out in the description box, and I will provide you in the cards. Now let's start 2A first chapter, which is complex numbers. The first sum is given as find the additive inverse of minus 6, 5 plus 10, minus 4. So solution. Thus minus 6 5 can be written as minus 6 plus 5i plus 10 minus 4i. First add this, that is 4 plus I. The additive inverse of, for example, z is minus z, so multiply minus with this, so this will be 4 plus I, that can be written as minus 4 minus 1. I hope you have understood the previous sum. So let's go to the next sum, which is given that if z is equals to 2 minus 3i, then show that z square minus 4z plus 13 equals to 0. So this sum can be solved in the two methods. The first method I will be explaining. Two methods I will be explaining. According to your feasibility, you can solve in any of two methods. So it is given that z is equals to 2 minus 3i. Take this z to LHS, that becomes z minus 2 is equals to minus 3i. So squaring on both sides, that becomes z minus 2 whole square is equals to minus 3i whole square. This is in the formula of a square minus b square, which is z square plus 4 minus 4z is equals to, this is minus into minus, that is plus, 3 whole square is 9, this is I square. So this becomes z square plus 4 minus 4z is equals to 9i square, where I square is equals to minus 1. So substitute this, z square plus 4z minus 4z is equals to minus 9. So the next step, bring this minus 9 to LHS. So that's it. In this procedure we can solve this. We have proved this, that's proved. In the next method, simply substitute z is equals to 2i minus 3 in this formula. So 2i minus 3 whole square minus 4 into 2i minus 3i plus 13 plus 13. So this is 4 minus 9 and minus 2ab, right? 2 into 2 4, 4 3s are 12, minus 12i minus 8 plus 12i plus 13. So the value of this is minus 5, minus 12i plus 12i gets cancelled, minus 18 plus 13. This is minus 13, this is plus 13, which gives our answer to be 0. Thus proved. Coming to the next question, it is given that if z1 is equals to minus 1 and z2 is equals to minus I, then find the values of augment of z1 into z2. Solution. From this we know the formula as arc z1 plus arc z2. The formula of arc z1 into z2 is arc z1 plus arc z2. So let's find the values of arc z1 and arc z2 to find the value of this. So it is given that x z1 is equals to minus 1. Apply augment. So arc minus 1 is pi. You can ask me how you have got the value of arc minus 1 as pi. So this can be written as 0 plus I, right? So this is x and this is y. Argument is tan inverse of y by x. Tan inverse of y is 0. So this becomes 0. Tan inverse of. So you no need this all explanation. So simply by heart this table. If the value is minus 1, then the angle becomes pi. Simply in this procedure, the arc z1 value is pi. Arc z2 is equals to minus I. So minus I means minus pi by 2. Arc z2 is minus pi by 2. So substitute this. Arc z1 plus arc z2 is equals to pi minus pi by 2, which is pi by 2. That's it. I hope you have understood the previous sum. So let's go to the next sum, which is given that if z is equals to cos theta comma sin theta, find the value of z minus 1 by z. Solution. Z can be written as cos theta plus I sin theta. And the value of 1 by z is 1 by cos theta plus I sin theta. There is a rule in complex numbers that you should not have imaginary term in the denominator. So in order to eliminate the imaginary term, rationalize the denominator. Rationalize. That is multiply by cos theta minus I sin theta by cos theta minus I sin theta. So 1 by z is equals to cos theta minus I sin theta by, this is in the formula of a plus b into a minus b, that is a square, that is cos theta whole square minus b square I sin theta whole square. Cos theta minus I sin theta by cos square theta, and this value is I square sin square theta, and the value of I square is minus 1. Minus of minus is plus. So finally this value is cos theta minus I sin theta. Now substitute in this values. Substitute the values in this. Z minus 1 by z is equals to cos theta plus I sin theta minus of cos theta minus I sin theta. Multiply minus inside the brackets. Cos theta plus I sin theta minus cos theta plus I sin theta. Cos theta and minus I sin theta, cos theta and minus cos theta gets cancelled. So the final answer is 2I sin theta, or this can be written as 0, 2 sin theta. That's it. Coming to the next sum, it is given that find the real and imaginary parts of the complex number a plus ib by a minus ib. Solution. If you consider z is equals to x plus iy, x is real part and y, which is coefficient of y, that is imaginary part. So let's start solving the sum, which is a plus ib by a minus ib. As discussed in the previous sum, we should eliminate imaginary part in the denominator by rationalizing the numerator with the conjugate terms. A plus ib by a plus ib, which is a plus ib whole square by a minus ib by a plus ib, which is in the formula of a square minus b square. A square minus I square b square. This is in the formula of a plus b whole square, which is a square plus b square plus 2abi by a square. The value of I square is minus 1. Minus 1 of minus 1 is plus, so that is b square. In the numerator, a square, the value of I square is minus 1. So this becomes a square minus b square plus 2abi by a square plus b square. Now divide the denominator with real part and imaginary part. So that is a square minus b square by a square plus b square. This is real part. And 2ab by a square plus b square is imaginary part. That's it. I hope you have understood the previous sum. So let's go to the next sum, which is given that find the multiplicative inverse of 7 plus 24i. So the formula of multiplicative inverse of z, for example, is 1 by z. So multiplicative inverse of 7 plus 24i is 1 plus 7 plus 24i. We have to eliminate the imaginary part in the denominator by rationalizing the numerator with the conjugate terms by rationalizing. That is 7 minus 24i by 7 plus 24i minus 7 minus 24i. This is 7 minus 24i. This is in the formula of a plus b into a minus b, which is a square minus b square. A square is 7 whole square minus 24i whole square. 7i minus 24i by 7 whole square is 49. And I square value is minus 1. Minus of minus 1 is plus. 24 square is 576. So 7 minus 24i by 576 plus 49 is 625. So this is the multiplicative inverse of 7 plus 24i. If you find this video to be informative, please like, share and subscribe. Stay tuned to the next series of videos. Thank you.